Hi, Algebra 1 students. It's Mrs. Kerr. Today we are going to do more notes, but this time from topic 1.3. So you're going to notice 1.3 has more than just two examples. So this will technically just be part one of the notes from topic 1.3. The example and try-its will also be available on Envision online textbook as well, but they won't be exactly the same as what I do in the video. Because I feel like sometimes the videos need more explanation. But I always want to give you the option to be able to go to the online textbook to look at the examples and read or watch the videos that they give you as well, just as an extra resource. So today's content objective, students will be able to demonstrate how to solve a multi-step equation with variables on both sides of the equal sign by completing inverse operations. Students will also be able to demonstrate if an equation has one solution, no solution, or infinitely many solutions. And how you're going to do this is by the language objective. So you will write the inverse operations in each step to find if the equation has a solution or not. And then students will listen to the video and will write the steps as I'm writing them in the video. Now, I just want to show you real quick on Envision what you're going to see. So I'm going to share this with you on the online textbook. Once again, the essential question is, how do you create equations with variables on both sides and use them to solve problems? I can write and solve equations with one variable on both sides to solve problems. So today we're going to go over example 1 and example 2. So for number 1, it says solving equations with a variable on both sides. What is the value of x in the equation shown? 3x minus 10 plus 4x equals negative 2 times the quantity x minus 4 plus 9. Now I'm going to switch over to my writable screen. So you can do this a few different ways. Just make sure that you show me work. So either highlight or circle 3x and this positive 4x can combine because it's on the same side of the equal sign. So then it tells us 3 plus 4, which is 7x minus 10. Now you're technically allowed to distribute at the same time because it's just making things simplified. So negative 2 times x is negative 2x. Now be careful, I keep seeing errors. It's negative 2 times negative 4, which is a positive 8 plus 9. Now notice that we distributed on the right, combine like terms on the left. I want you to combine on the right in a separate step. You don't want to do too much in one step, or I'm not going to be able to follow correctly. So then we have 8 plus 9, which gets us 17. Now, there's different directions that you can go for this next step. Some students may see minus 10 and they want to add 10. That is fine. Some students may want to minus 17 on both sides. That's fine as well. Whichever way you choose, just make sure that you keep that line down the middle so you know what happens on the left and what happens on the right. I strongly suggest that you always try to move the variable to the left, because we are going to get into inequalities in about a week or two, and it's easier to read that statement when the x is on the left. So notice that the minus 2x is together and it's being minused. So now I can travel to the left by inverse operation. I'm allowed to do that because 7x plus 2x are like terms. And then I have 9x equals 27. Divide by 9. So then x gets me 3. Now, you are going to learn in a couple minutes that there are different answers. This is actually technically called one solution. There is only one number in the entire universe that makes this true, and that is 3. If I plug 3 back into every spot I see an x, I would get a true statement. I would get the left side equal a number and the right side equal the same number. So let me just check my answer and show you what I mean. So I have 3, and then I have 3 minus 10 plus 4, parentheses 3, equals negative 2. Plug in that 3 again, minus 4, plus 9. So if I simplified this, I got 9 minus 10 plus 12, and then simplified this, which is negative 1. Negative 1 times negative 2 is 2 plus 9. So then I would get 11. And then this would be negative 1 plus 12. And then 11 equals 11. So that's how I know that that's correct, because I got a true statement. So 3, in this case, is the only number in the entire universe that would work for x. Now, if you go back to the Envision, they may show you a different way. They distributed the negative 2 rather. They combined like terms, and then they divided. So that's how they showed that work. Now for part B, it's very similar. Now part B, for example 1, is very similar, like I was trying to say, except that it has a fraction. And we don't really need to find the LCD because there's only one fraction. So you want to look at the denominator, which is 2. We're dividing by 2. So that means we can multiply the whole equation by 2. Now, since that half is touching the parenthesis, I really just have to multiply that, that 1/2 by 2, which gets us 1. And then I don't have to touch anything in the parentheses because I just took care of multiplying there. Now 2 times negative 7, because it's outside the parenthesis, is minus 14. All the way on the other side of the equal sign would get us negative 4n. And then 2 times 6 would get us 12. Now, technically, we could multiply that 1, but 1 times anything is itself. So then we have 1n minus 4 minus 14 equals negative 4n plus 12. Now, we can clean up this side right here. We have negative 4 minus 14, which gets us negative 18. We have 1n. And then negative 4n plus 12. At this point, I really recommend you move the variable and the number in front over to the left. So we add 4n on both sides. So then we have 5n minus 18 equals 12. Add 18 on both sides. Then we have 5n equals 30, and then we can divide 5 on both sides, and then we have n equals 6. So you can check your answer by putting 6 into n on both sides, and you should get a true statement. Now you could go back to the actual book, and you can see, and then it's basically the same steps. It said multiply each side by 2 to eliminate the fraction. So we did that. And then they call it collect like terms. I combine like terms. So they moved the minus 4n. They added 4n on both sides and added 4. So the one thing I do not like about this way is that they did not show you the inverse operations on both sides. So you would technically not get enough credit if you do the way that they do. So I really need to see this part. I need to see it on the right. I need to see it on the left. I need you to add 18 on the left and then on the right. Notice that I'm doing the same operation on both sides of the equal sign. So make sure that you're showing me that. They didn't because they actually wrote it out, which we're not requiring you students to do. Now what I would like you to do is pause this video, and then you're going to attempt the try it. Now the nice thing about having it on the online textbook is that once you try it, you can actually type in your answer to see if you were correct. So I recommend you going to the Envision online textbook and putting in your answer to the try-its. And if you did not get it right, that's okay. Just make sure that you watch the video that I'm about to do so you can correct those mistakes.